Mathworks is created of MATLAB and Simulink. And with us today, Louvere Walker-Hannon is a senior applications engineer for Mathworks, providing direction and recommendations on technical workflows for various applications. She has a long history of serving as a STEM mentor and volunteers with Black Girls Code and the Society of Women Engineers. Shruti Karulkar is the quality engineering manager of MATLAB hardware at Mathworks. Shruti has a long history of serving as a STEM mentor and STEM ambassador for Mathworks. Mohamed is a software engineer at Mathworks, working on deep learning interoperability. She has experience organizing and delivering hands-on workshops at the Grace Hopper celebration, as well as Tech Together Boston. We will be presenting Pocket AI and IoT, or how to be a data scientist using your mobile device. TAs are online to answer your questions. So go ahead and take it away.
Thank you, Cerise. Let me go ahead and share my screen. Can everyone see my screen okay? Perfect. So good morning, good afternoon, and good evening. Thank you for joining us today for our hands-on workshop, Pocket AI and IoT, where you will learn about machine learning, sensors, and IoT, and turn your own mobile devices into a smart fitness tracker. So let's get started. With us today, we have few amazing women from Mathworks joining as our teaching assistants. Welcome and thank you, TAs. They will be helping answer any questions that you might have. So please feel free to use the chat window to ask any questions, any issues that you run into as you start doing the exercises. So we know all of you came here to learn more about sensors, AI, and IoT. And we are going to use application of a smart fitness tracker to bring together all these different buzzwords. How are we going to learn about them? We are going to learn about sensors. We are going to see how they are used to track our movement. You might have noticed that I keep saying smart fitness tracker. What brings smartness to a fitness tracker? It is AI, and you are going to learn exactly how AI does that. Last but not the least, you are going to see how IoT plays an important part in a smart fitness tracker. Let me tell you a quick application, how I use my fitness tracker. I use it to compete with my sister to do a step challenge to see who amongst us took more steps in the day. And IoT makes that happen. So with that background, let's get started. Before diving deeper, I want to tell you a quick trivia. Do you know, just in the last year, all across the globe, $26 billion were spent in the wearable tech industry? That's how huge this industry is. And today, we are going to cut through the hype and tell you what this whole industry is about. In this workshop, we are going to introduce the concepts of sensors, AI, and IoT, and follow them up with hands-on exercises. We are going to build our smart fitness tracker incrementally via the 3 exercises. So the goal of the first exercise is to turn your mobile device into a step counter. The reason I say mobile device is because you can use either your phones or tablets to do this exercise. In the next exercise, you are going to use a machine learning algorithm to classify activities, to classify whether you were walking or running. In the next section, you are going to see how easy it is to read and write data to an IoT aggregator. We are going to write how much duration was I running or walking to an IoT aggregator. So let's see what are the different technologies we are going to use today in this workshop. To implement AI, we are going to use MATLAB. MATLAB is a programming language that is used for technical computing and engineering. For learning more about sensors, for accessing sensors, we are going to use MATLAB mobile app. This app can be accessed on both iOS and Android. For learning more about IoT, we are going to use Thingspeak. Thingspeak is an open IoT platform with MATLAB analytics. So these are the different technologies that we are going to use today. So let's start with our first section for today, which is sensors. Let me begin by telling you this. Sensors are all around us. A sensor is a physical device that measures movement and responds to it. Can you tell me what are the examples of sensors that come to your mind? Any sensors you think you use on a daily basis? Let me know via the chat window. The few examples that I can think of are the thermometer, humidity sensor, pressure sensor, etc. Now let's look at more examples. Fitness devices, that's what we are going to do today. Virtual reality devices like the Oculus Rift and wearable tech. What you see here is a baby who is wearing an owlet sock. This sock has sensors in it, which helps us monitor baby's blood oxygen levels and heart rate. Now, this sensor data can be accessed on a mobile phone in an app. This is how parents can track how the baby's health is. These are few examples of devices which have sensors in them. One quick thing, all these sensors have one sensor in common. Can you guess what that is? Let us know via the chat window. Which sensor do you think is present in all these examples that you saw? The answer is accelerometer. Now let's learn a little bit about this sensor. An accelerometer is a sensor that detects acceleration, vibration, and tilt along the three axes. It helps us measure how we are accelerating in a linear direction. This is the sensor in your mobile device that helps us determine whether we are holding the device in a portrait or a landscape mode, or whether the device is facing upwards or downwards. You are going to use accelerometer sensor while we do our hands-on exercise today. And this is the sensor that we are going to use as we build our smart fitness tracker. So let's get into our hands-on portion of this workshop. Before doing that, let me tell you a little bit about our MATLAB mobile app. The app would look something like this. Once you get into the sensors page, it should look like this. The first sensor that we have highlighted here is the accelerometer. Let's see a short video that will help us navigate in the MATLAB mobile app. So as you open the app, you should see something like this. Click on the hamburger menu. It will take you to these options. Select the sensors option. Here, you will be seeing an option which says stream to. Select that and change it to MATLAB because we want to log all our sensor data into MATLAB because that's where we want to process our data. Next, click on the More button. Here, we want to allow programmatic access to the sensors in our phone because we want to get our data from our accelerometer. Go back to the main menu. Click on the Files button. For those of you who have already done the pre-work, you should see a folder named Pocket AI and IoT. This folder will have all the exercise files ready for us. Don't worry, if you haven't done the pre-work, you have the opportunity of doing that as we start doing the first exercise. But after doing that, you should be able to see our exercise files. Okay, so once you are in it, I'll talk you through which code file to use. Okay, so now let's see what is the goal of our first exercise. What are we going to do in it? As I mentioned before, the goal of our first exercise is to turn our mobile device into a step counter. And how are we going to do this? We are going to enable or turn on the accelerometer sensor in our phone. Next, we are going to walk. So this is a fun exercise where you get to move around and have fun. We will be collecting data from this sensor as you walk. Next, we are going to do some data analysis on the acquired data and then count the number of steps that you took as you were doing this exercise. Now, let's look at the code at a high level that will help us achieve this goal. Now, this is an helper function. You don't have to run this file. This file will be called in the exercise file that we will tell you to run. But this is just for all of you to know. We will begin by creating an object that helps us make a connection to the mobile device on which our MATLAB mobile app is running. Next, we will turn on the accelerometer sensor in our device. That's what we are doing in this helper function. Next, we have our exercise 1 file. Now, this is the file that you are actually going to run. In this code, what we are going to do is we are going to first get the acquired data from our sensor. We will then do some data analysis on the acquired data. Our goal is not to go into data analysis portion in this workshop, but we have very well documented code that will help you orient yourself and so that you can follow along why we are doing exactly this step. We will next determine the number of peaks in the acquired data because number of peaks is equal to the number of steps that you take. Okay, so when I did this exercise, I got an output which looked something like this. 45 that you see here, that was my step count. So when I was doing this exercise for 20 seconds, I took 45 steps. Pretty good, huh? On the lower right-hand side, you will see a plot. Click on the plot. So this should show you, the blue lines show the accelerometer sensor data. The red triangle that you see here are the peaks. These peaks correspond to each step that you take. Okay, now let's see how we are going to do this exercise. Open MATLAB mobile app on your device. Navigate to the exercise file, which is exercise 1 count steps, and press the run button. Once you do this, you will see an evaluating or a spinning wheel. The spinning wheel does not mean that your program is hung. It just means that your programming is being processed. You will then be prompted to press the return key. After you press the return key, that is when the data acquisition will begin. Walk for 20 seconds. At the end of 20 seconds, you would be able to see the step count. I would like to highlight 2 things here. One is you don't have to keep a track of time. Our program is going to count 20 seconds for you. Next, I would like to highlight walk naturally. You don't have to look at your device. Walk naturally as you would holding the phone on the side. That will help you get more accurate count step. Okay, so we are going to take 3 minutes to do this exercise. It's 11:58 Eastern Daylight Time. Let's regroup at 12:01. Let's get started. As and when you are doing this exercise, if you run into any issues, please feel free to ask our TAs any questions using the chat window. We have 1 more minute to finish our exercise. Okay, it's 12:01. Let's regroup. How many of you were able to run the exercise? Let us know via the chat window. Okay, for those of you who weren't, it is okay. You will have opportunities to run similar code in the next 2 exercises. So for those of you who were able to run the exercise, do you think you got accurate results? Were those the correct number of steps you took? If they weren't accurate, why do you think they weren't? A quick hint that I can give you here is how you hold the phone. What was your stride? All these are the factors that impact the accuracy of the algorithm. So thinking more, if you want to explore sensors more, what are other sensors that you can possibly collect data from and build new application? Be thinking along these lines. And with that, I will hand it over to Sarah for the next section on artificial intelligence. Over to you, Sarah.
Thank you, Shruti. And hello, everyone. Let's go ahead and revisit our roadmap for building our fitness tracker. In this last exercise, you learned how to collect accelerometer data from your phone and analyze it to get some useful information like step counts. But we told you that we were going to make this fitness tracker smart. So now we're going to incorporate some artificial intelligence or AI to allow the fitness tracker to make some interesting guesses about what you're doing as you're collecting accelerometer data. If we could go to the next slide. Let's think of some daily applications of AI that we might see in our lives. Even if we don't have a formal definition, we can probably think of some examples. For example, if you have a smart speaker like an Echo or a Google Home, then you've been interacting with artificial intelligence. You talk to this device, it tries to understand what you've said, and then tries to answer your query or complete your request in a smart way. You might have other smart home devices like a Nest thermostat. And there you've probably seen how you can use AI to modulate the temperature of your home to try and conserve energy when the seasons change. So we can maybe think of other examples in our daily lives as well. The sort of common theme that unifies them is that AI is about making machines behave in what we think of as an intelligent way. But AI is just one piece of a system, like in our fitness tracker, that makes the system smart. So there's a lot of buzz around AI today. And you might have heard of different types of AI, like machine learning. I would think of AI as an umbrella term that can cover many different types of intelligence, but the one that we're going to focus on today is machine learning. So let's drill into that a little bit more. In machine learning, we want to build a model that can accomplish some task. So we can think of this model as being a black box first, which has inputs and outputs. Let's say our task is to classify what activity that we're performing while we're holding our phone. We start with some data, like the accelerometer data that you practice collecting in exercise 1. Then we give that data to our model, and the model classifies our activity as walking or standing still, for example. Let's understand how we created this model by opening up that black box and talking about some of the additional steps that we need to perform in order to train it or teach the model how to accomplish its task. So next, please. You had a chance to examine the raw accelerometer data from exercise 1. There were 3 vectors, X, Y, and Z. Instead of feeding that accelerometer data, raw accelerometer data directly into our model, we're going to perform a step called feature extraction. And feature extraction is all about transforming our data or selecting pieces of our data that we think are going to help it accomplish its task well. You might not want to give the raw data to the model. So for example, maybe instead we could apply some statistical methods to it, like normalization, so that all of our values kind of fall within the same range. Or maybe we might want to pre-process our data by looking at it in 5-second windows and then see what changed within that period. Did you move up or down or left or right? The extracted features that you're going to give to your machine learning model is what we'll use to train it. And there are many different types of training algorithms that you can use, including some of the ones listed on the screen, like decision trees or support vector machines. But the one that we're going to use today is called nearest neighbors. And you'll learn a little bit more about nearest neighbors in the next exercise. So these 3 different types that are shown here are all types of what we call supervised machine learning. And supervised just means that the training algorithm requires both the features from the data as well as labels for them. So for each data point among our features, we need to tell what activity that we were doing. So we're going to use k-nearest neighbors to classify the activity that you're performing using accelerometer data that you collect. But what's KNN exactly for those who maybe haven't used it before? So the goal of KNN is all about finding the k closest points to some query point. And you can choose different ways of measuring closeness using different distance metrics. K in KNN is just the number of neighbors that you compare to determine how to classify your query point. In this diagram, let's imagine that our smiley face is our query point. And we're going to use k equals to 3, meaning comparing to 3 neighbors. So let's say that we're just using Euclidean distance here as our distance metric. The 2 red walking icons that you see and the 1 orange idle icon are our 3 nearest neighbors. And since the majority of our neighbors are walking, then we would classify this new query point as walking as well. And this is kind of the simplicity of KNN, which is the algorithm that you'll use in this next exercise to classify your activity using accelerometer data. So if we advance one more slide, let's talk about how you're going to apply this to your fitness tracker now that you've learned a little bit more about what you'll use. So in exercise 1, again, you learned about the accelerometer data on your phone, and you demonstrated one way of analyzing the data. Now in exercise 2, you'll collect new accelerometer data, and you're going to apply k-nearest neighbors to predict whether you are walking or running or standing idle. So this is going to be a great chance for you to get up out of your chairs and move around a little bit. So let's walk through the main parts of the code together. The file will be called exercise2 classifyActivity.m. And the first thing that you'll do is grab some of the data that we've already collected for you. And you'll use this training data to fit a k-nearest neighbors model. The number of neighbors that we're going to use today is 10, and so we'll set k equal 10 in the model. Next, we're going to extract features from the raw accelerometer data. And if you'd like to see exactly which features we extract, you can take a look at the file extract features in the helper folder, where we've documented what we did. And then finally, we'll predict or classify the activity that you were performing and give you a probability score of how confident we are in the model's prediction. All right, so after you've run the exercise, this is what output you should see. You can click on the plot to see a breakdown of your activities across time. And this is sort of the plot that you'll see. Along the x-axis, we have our time steps, and then you should see about 3 horizontal lines corresponding to the 3 different activities that we can predict. So a dot will be shown on the plot for each time step at which you were doing that activity. So go ahead and open up the file exercise 2 classify activity and press that green run button. You can press the return when you're prompted to start logging that data, and then just move around for about 30 seconds. But make sure that you're trying to sort of vary your activities so that you see an interesting looking plot and can really evaluate how well the model is predicting. And then finally, you'll be shown that plot from the previous slide with a breakdown of your activity across time steps. So if you have some extra time, you can try again and review the code. So let's take 3 minutes again for this exercise. It's now 10 minutes past the hour, so let's reconvene again at 13 minutes past the hour. All right, let's go ahead and reconvene. It's now 13 minutes past the hour. If you didn't have the chance to finish running the exercise, don't worry about it. You'll actually have another opportunity to try and classify your activity in the next exercise as well. So in general, did you all get the results that you were expecting? Did the classifier do a good job of labeling what activities you were doing across time? Let us know in the chat how things were going and what sort of results that you saw. And we might also think about how we could improve the accuracy, maybe by changing different parameters in the model, or maybe even by changing the features that we use to train the model. Some of you might have taken a peek at the extract features function to see what features we were using to try and predict our activity. But what other features or perhaps even sensors could be used for collecting data and trying to classify activity? An easy parameter that you could change if you just wanted to try and play around with the model in a simpler way would be to change the value of k. If you remember, we said k is referring to the number of neighbors that we are comparing a new query point to. And when you ran this code, the default that we set it to was 10. But you might ask the question, is 10 the right value to use? What would happen if we increased the number of nearest neighbors we use to evaluate a query point or decreased it? So play around with that value and let us know how it affects the different results that you get. So if we move on to our next slide, Lou is going to walk you through incorporating the Internet of Things, or IoT, into our application. So I'll hand it off to Lou there.
Thank you very much, Sarah. And I don't know about all of you, but I think that last exercise, actually the last two, is pretty interesting. So as Sarah pointed out, we're going to move into highlighting information related to the Internet of Things. The next slide, please. So as a part of the Internet of Things, what does this mean? We're going to be able to take data from a variety of devices and collect this data. Next, after we collect this data, we'll typically try to analyze patterns or trends. And finally, as a third part of this process, we're probably going to have some sort of action after we implement our analysis. And that action could entail sending an email message, sending a tweet, or doing something else. Now, one of the major themes I like to point out for us is one of the big pieces of using the Internet of Things is being able to collect data from different devices that are not in the same physical space, where you probably are thinking, I see a connection to this workshop. The next slide, please. So as a part of the Internet of Things, this brings us to our third and final exercise, where we're going to collect our activity data on the cloud and try to do some analysis with this activity data as well. The next slide, please. So in terms of collecting our data through the Internet of Things, we're going to use an open IoT platform. What is the name of this open IoT platform? It is called Thingspeak. And you can visit thingspeak.com to see more information about the IoT platform itself, as well as the types of different activities you can implement when you use Thingspeak. Today, we're going to be using Thingspeak as a part of our third and final exercise to help collect our data, aggregate our data, and do some analysis. The next slide, please. So in terms of using Thingspeak, this open IoT platform, one of the items that you're seeing in the slide is you're seeing a visualization of a lot of the content that may look familiar related to different individuals who were collecting their activity data and seeing what people were doing at certain points in time. Now, if you look closely at least one of the visualizations, the visualization that says fitness challenge, and on the x-axis, you see different users. These were different individuals who took this workshop at another point in time, and they collected their data, and using this IoT platform, Thingspeak, we can compare and see what people were doing at different points in time. Notice on the y-axis how it has total time measured in seconds. So it looks like one of the users, for example, may have been walking the entire time, while one of the other users may have switched between activities. So hopefully, after we do our next exercise, we can see some similar visualizations. Next slide, please. So for our next exercise, you're going to aggregate your team's activity time. Now, just for clarification purposes, you may not necessarily have a team that's dedicated for this workshop. So instead, my suggestion is when you're prompted for a team, maybe just use the numbers 1 through 5, just so we can have some way of seeing information related to different groups. But first, let's look at this overview of the code that you're going to execute as a part of exercise 3. So first you have Thingspeak Write that is going to tell us what information we're going to take, and also pointing out this channel ID where we're going to make certain we write this information to. So we see that here for Thingspeak Write. And the next slide, please, or next part of the slide. And then we're going to actually do the opposite after we write the data to a particular channel using Thingspeak. We're now going to read this data. We're now going to import this data and make certain that we get access to data, not just in a particular channel, but was also recorded during a certain amount of time. So notice how you have this parameter num of minutes, and we have this variable num minutes. So we're actually collecting data within the last 2 hours, which should be during this time frame that we're holding this workshop. Next, we also have the following. So after we get access to this data, we're going to have a visualization of this data in the form of, should be a bar graph. Next, please. Now, in terms of us and our own view as we collect our data, we can examine this figure to view what everyone was doing. So notice, for example, in this visualization, we see on the x-axis how we have the activity, we have categories, and along the y-axis, we have that total time, once again measured in seconds. And we see this information overall, where we're supposed to be able to view the information for all of the people that collected their data during this time frame that we have together. So it looks like in this case, for this example, looks like a lot of people were running versus walking, and we may see a similar visualization coming up soon. The next slide, please. And before we do the exercise, I'd like to walk you through these steps and give you the time frame for doing this exercise. So number one, let's return to MATLAB Mobile and visit the following file. The file name is ex3_thingspeak_fitness. And let's press that green run button. When prompted, enter team ID. Once again, my recommendation, let's use numbers 1 through 5 to have some way of being able to say we have these different groupings, and press your return key. When you press that return key, you'll be prompted to start logging. Please move. So we have these 3 activities: walking, running, or remaining idle for 30 seconds, and then view the fitness activity from hopefully all of the teams. If you do have any additional time during the time that we're doing the exercise, please try to follow these steps again. Currently, time-wise, it is 12:21 p.m. Eastern Daylight Time, and let's take 3 minutes for this exercise. So I'll check in again at 12:24 p.m. Eastern Daylight Time, and please visit the chat to refer questions to the teaching assistants. Thank you, and I'm curious to see these results. Once again, check in again at 12:24 p.m. Eastern Daylight Time. Thank you. Just to do a time check, it's now 12:22 p.m. Eastern Daylight Time, so some time left, about 2 minutes. And just to check in, it is 12:24 p.m. Eastern Daylight Time, and we'll check in related to this exercise. First of all, I hope it was informative. I hope we're able to collect data, and coming up soon, we'll maybe try to get a visualization to see, how many of us may have collected data. I do want to quickly address one question that's in the Q&A panel. So the question was, will I be able to do the exercises at a later time, or will Mathworks permission not be allowed? Thank you. So in terms of that question, you will be able to do the exercises after this event. Now, in terms of the MATLAB Online license, that is a limited amount of time. So that license will be available for a week after this event. In terms of the material such as the presentation and the example and exercise files, that will not expire, but the access to MATLAB Online will, and we'll talk about that a little bit later. So thank you for that question. And let's continue. So in terms of the exercise, we do have an opportunity to look at a visualization in regard to these results. And if we'd like, we can click on this hyperlink for the fitness challenge to try to see, for the fitness channel, I should say, to try to see if we have any visualizations related to all of the different teams. Keep in mind, some of us may have chosen certain team numbers for a variety of reasons, but in this particular case, you should be able to see a visualization of your own information through MATLAB Mobile on your mobile device. And we will continue from there. Now, one thing to consider as you obtain your results, we have the following questions. So one item is, what else could we do with this data that we've aggregated? And we can do a variety of activities. Some of these activities could be related to, trying to see if people in certain regions had certain types of information, certain statistics, and a host of other activities. The other question too that's there is, how can we think of other applications in our day-to-day lives where we could see machine learning and IoT come together? And that brings us to some of our last topics. But one of the first topics is to say congratulations. So you have cut through the hype to design a fitness tracker using quite a few items on your mobile device. One of the biggest items is, with this fitness tracker, you are able to learn and get an overview related to working with sensors, machine learning to classify your data, as well as using IoT to help aggregate data from various devices and look at trends and patterns. In other words, a lot of activities for being a data scientist. Next slide, please. And there are many real-world examples of using sensors, AI, and IoT. In terms of these examples that we're seeing on the slide, many of the examples tend to come from the medical world. However, one example that's in my lower right-hand corner highlights taking data from various devices that are out in the world and being able to classify certain types of vegetation to maybe determine information related to the type of crops that may be available, as well as maybe information related to, are we getting enough, let's say, water in certain regions. In terms of getting access to this content, you'll have some information after this session. Next slide, please. And in terms of this session, think of this as a starting point for being able to learn more about these topics. And one theme we have here, please continue to learn after this session. So on this slide, you have a series of Onramps. These are free tutorials that can help you dig a little bit deeper related to many of the topics that were highlighted related to this workshop. Next slide, please. And finally, I want to say on behalf of our workshop team, thank you so much for attending this session, and we hope you found this session informative. If you would like to continue the conversation related to any information that you found interesting or your results, please use these hashtags, SheLovesMATLAB, Pocket AI, and IoT after this workshop in various forms of social media. You have the contact information not only from myself, but my various colleagues, and the @ symbols highlight the Twitter handles of each of us, and you have our direct Mathworks email addresses. If you had any questions specific to AI and also how to get access to tools, especially for your applications, please feel free to contact me. That's part of my role as a senior application engineer. Thank you once again for your attention. We hope you found this session informative. And that is it for our workshop.